Welcome to Electronics Techie. So in this video we discuss about half subtractor Verilog code. So in previous video we discuss about some other Verilog codes, but in this video we discuss about half subtractor Verilog code. So how the representation means, it seems like this. So you can see that in half adder and half subtractor the only difference is whatever in that they will get generate carry, but here in half subtractor the borrow will come. So in the difference the formula is same, A XOR B, whereas borrow is also same as carry, but there is a inverted output of A, so it is nothing but AND operated with B. So it is like this. So we have one of the input is connected to NOT gate, then we can generate borrow. So it is our formulas for half subtractor. How you can generate half subtractor means, so the difference is generated by A XOR B operation, whereas borrow is generated by inverse operation of A and AND operated with B. Like that we can generate the difference and borrow of the half subtractor. How are the truth tables means, they are the two variables. 2 square is nothing but we get 4 combinations: 0 0, 0 1, 1 0, 1 1. This is A values, this is B values, and the difference and the borrow. So difference and borrow, 0 0 for the difference is 0. So means again you can substitute this formula, inversion of 0 and operated with 0. So invert of 1. So 1 and operated 0 is nothing but 0. So like that you fulfill the whole truth table. So 0 1 is nothing but, again we can done. So 0 XOR means, so 1, and the borrow is also 1. So like you can use these formulas and fill the whole truth table. So for 1 0 combination the difference will be 1 and the borrow will be 0. So for the difference will be 0 and the borrow is also 0. You can substitute these AB values in these two formulas, then we get the difference and borrow values. Like that half subtractor theoretical part will done. So how can you write Verilog code means, just see. So for every design code we have every time discuss that the Verilog code is start with module and end with end module keywords. So for module we have to write the module name. So here I, according to Verilog design, so it is a half subtractor, that's why I represented with half underscore subtractor. It is a module name. So what are the inputs here? A, B are the inputs. So that's why I represented input keyword A comma B. So A and B are the input ports here. So A, B are the input ports. That's why I simply represent input A comma B. So what are the outputs here? Difference and borrow. But in Verilog code I simply write difference comma carry. So if you are familiar with borrow means, then you can simply replace carry with borrow. So no problem, according to your understanding you can write anything. So output, so I write difference. So if it is a more large means, you simply written C comma D comma B or D comma C. So difference is represented by D. So you can use any name, but it not should be keyword. So you can use any name, but it not should be any inbuilt keyword in the Verilog language. So I simply write the output ports with output and the difference and the carry, like that. So what is the formula for difference? Now only you see that A XOR B is the difference formula, and end operation of NOT gate of A and B are the borrow. So here I simply write like that. So just I simply use assign keyword. It is a data flow modeling style like that. So that's why I use assign keyword to assign the value of RHS side to LHS side. So now what I have to do? So for difference variable, so I initial means I send the value of A XOR B, means whatever the value in the RHS side will assign to the LHS side. So by using assign keyword, so I simply write different equal to A XOR B. For the logic gates we have symbols, so it is XOR gate. So for assign carry is equal to inverse of A and operated with B. So I simply write this formula to carry and assign it by assign keyword and stop with end module. So this module is closed with end module. It is about design code. Till now if you have any doubts you can comment it. So just look into the test bench code. So how the test bench code looks like, same here also module start with module and end with module. So here also in test bench code also every Verilog code start with module and end with end module. So module, and after what is the after module, you know that module name will come. So it is a test bench, that's why I simply add the half underscore subtractor underscore TB like that. So every time I say that whatever the input ports that will be represented in reg, so whatever the output ports we can represent it, but wire means net data type. So every video I say that why you use only reg means, so input ports we can use reg data type or net data type. Net data type, whereas output will be only net data type. So why you don't use net data type means, the reason is, so here whatever the AB values we use in the initial block. So whatever the values which are represented in the initial block, it must should be the reg data type only. So that's why we use reg data type. If you don't mention anything in the initial block, so you can use wire also. So but because of initial blocks we use reg here, so don't forget about this. So every time I say means it is a very important point. Why you use reg only means this is the main concept behind this. So for reg, if you don't use reg wire means you can get error, because initial block, whatever the initial block, you have to use the reg statement only. You can see in behavior modeling style also we use always block. In design code we use always block. In output, after output you put simply reg. Why you put reg? Because whatever in behavioral there are the two blocks, initial block and always block. Whatever the keywords we have to use, whatever the values which are initialized in this, in the inside the block of always or initial, it must should be the reg data type only. So that's why you mention reg every time. You have to see that. So you have to use reg data type. So it is the behind that, it is the reason behind that. So just simply write output in while. So here what I do, instantiation. So I have to simply write this module name half underscore subtractor and then space. You can use DUT or design under test, or you can use your name also, so no problem at all. So you can connect ports. So how we connect port means we already discussed that ports are connected by name or by order. So mostly we have to prefer by name. So you can prefer by order also when you have less number of variables. So here you can simply write a comma difference comma carry. So it is also okay, but if more number of variables means it is better to use by name. So port connection by name is most preferable for complex circuits. So till now you can use order also, no problem at all. So initial. So for whatever the values you have to given to the as input for serial implementation. So whatever the statements in the initial block, it must should be executed serially. But initial blocks are executed parallelly, but inside the statements what we have in the initial block, it should be executed in serial manner. Don't forget about it. If you have two initial blocks, it should be executed parallelly, but whatever the statements inside the initial block, it should be executed serially. So more number of statements, you simply write begin. So we have to give different combinations and we have to delay. So every code we have to discuss the test bench. So same as whatever the inputs we take, so give the values to the inputs and give delay, and again change some combinations and again delay. So change combination and again delay, like that. So if you want to stop the simulation, you can simply use the dollar symbol finish of braces and the column. So it means you have to stop the simulation by using this finish keyword. So this begin is end with end. So here the initial block will be completed. If you don't end with end means it should be error. So why you write 4 lines? I already say I use EDA Playground. It is an online compiler. So for generating a waveform, we have to use these 4 lines. So that's why I write this. So if you do in any other platform like Vivado, like that, so you have to ignore this. So no need to write these 4 lines. It is EDA Playground. If you want to generate waveforms, you must and should write these 4 lines. Otherwise you can ignore it. And end module. This module is end with end module. So first we have to represent module and the module name. So inputs are in reg data type, outputs are should be in wide data type. Next instantiation and port connections, like that. So what are the inputs? You can give the input values and stop the simulation and just simply end module. If you are doing coding in EDA Playground, you have to write these 4 lines to get waveform. So after the execution, the waveforms is look like this. So here you can see first 5 before 5 seconds. So before 5 seconds means it is the 5. So before 5 time units, the value should be like this. So after 5, so here see after 5 A is equal to 0 and B is equal to 1. So after 5 it will be again changed. Then again after 5 time units, so again it will be changed. After 5 the simulation will be stopped. So we have to understand that. So after a finished statement, the execution will be stopped and simulation will be ended. So what you have to see, so whatever the orange line it shows here, so it should be represent the values here. So here you can see A value is equal to 1, B value is equal to 0. So again go to truth table. What you have to return, A is equal to 0, B is equal to 1, the value should be 1, 1. Sorry, A is equal to 1 and B is equal to 0. So A is equal to 1 and B is equal to 0. So what is the outputs you have to get? Difference will be 1 and the carry will be 0. So 1, 0. So difference will be 1, carry will be 0. Here you can see difference will be 1 and the carry will be 0. So whatever you have done, the code will be right. We have to check by using these simulation values. So otherwise you can use display statements also. Maybe I try to how to write display statements in next video. So don't worry about it. It will be very simple. You have to simply use the display statement like that. So until then, it is about half subtractor code. So it is very simple as like half adder. So you have to simply use NOT gate at input A. So if you have any doubts, you can comment it, and thanks for watching. Until then, bye.